Welcome back, students. This is Megasham Raju, Assistant Professor in Mechanical Department, Engineering College, Bikaner. In the previous lecture, we have seen the stylus instrument, which is measuring instrument used to measure the finishness of a particular surface. How it is measured is like we will be measuring the roughness and we will be measuring the waviness of a particular surface. Then we will decide the how much finishness it is having, right? For that we have used one device called stylus. So now stylus and a datum instruments, okay, these instruments are of two types. One is true datum and the second one is an surface datum, so which are also called as a skidless and skid type. As I have discussed in the previous slide, so here you can see this is a skid type and this is a skidless type, right? In the skidless type instrument, the stylus is drawn across the surface by a mechanical movement and that results in a precise path. So this is my skidless stylus instrument, which is used to measure the finishness of the surface, and in this I don't have any type of a skid. So instead of, the stylus will be moving vertically and this movement is captured by a drive unit using some reference surface or a datum surface will be calling it. And now the path is the datum from which the assessment is made. Whatever it is having an path or a particular job is nothing but a datum for this drive unit. So this is nothing but an skidless type. Now in a skid type instrument, the stylus pickup unit is supported by a membrane that rests on the surface and slides along with it. So in skid type, it is having one membrane, and on that particular membrane the skid is relaying over it. What is meant by skid is like, you just assume an ball bearing type. If that ball bearing is just placed over that, or if you just assume an caster wheel for an automated guided vehicles. Sorry guys, I didn't have the picture of an caster wheel right now. If you just search in the internet, you can see the caster wheel. Caster wheel will be having a big ball bearing, and if you are just pressuring over that caster wheel, the ball bearing will be going inside, and if you just remove your pressure, the ball bearing will come out. In the similar way, the skid will also be in the similar fashion, it will be working. In the skid type instrument, the stylus pickup unit is supported by a membrane that rests on the surface and slides along with it. That's what I have told you by taking one example of a caster wheel which is having a ball bearing in it. This additional membrane is a skid or a shoe. You can call this additional membrane is either it can be called as a skid or a shoe. Shoe is nothing but an it will be having a flat surface, but the skid will be having some rounded surface. Skids are rounded at the bottom and fixed to the pickup unit. The pickup unit is nothing but here a drive unit. They may be located in front or behind the stylus. The skid can be placed behind the stylus or in front of the stylus based upon your application. The instrument can be manufactured. Once it is manufactured, you can't change the place of a skid. Some instruments use a shoe as a supporting slider. That's what I have told. Instead of a skid, shoes are flat pads with swell mounting in the head. Swell mounting is nothing but it can move in any direction It can move in any direction freely with just going inside and outside. It can go inside and outside. Vertical, a little bit of an vertical motion is also happens in this shoe. The datum, whatever the reference created by the skidder shoe, is the locus of its center of curvature as it slides along the surface. What is meant by a locus? Locus is nothing but it is an line or the curve drawn over a particular motions of the skids. So for example, if my skid has followed a curvature of this curve, okay, then the center point of this particular skid connecting all the contours of the skid is nothing but an locus. That's what he mentioned here. The datum created by the skid or shoe is the locus of its center of curvature as it slides along the surface. The stylus is typically a diamond having a cone angle of 90 degree. Cone angle is nothing but, if you just see the stylus here, so this is nothing but my cone angle. If you just refer some internet, Google, you'll be getting a cone angle. What is meant by cone angle? I thought of giving here, but I have forgotten. I didn't included that particular image here. And a spherical tip of 1 to 5 micrometer or even less. So whatever tip it is having an 1 to 5 micrometer. Generally, the stylus having an pointed tips are used to measure the roughness of the particular surface, and a blunt stylus means a pointer which is having some blunt sharpness, sorry, not a blunt sharpness, a bluntness is used to measure the waviness, and this measurement of this waviness and the roughness will result into how much finishness the job is having, or while you are manufacturing, how much finishness you got will be resulting by this waviness and roughness measurement. So the stylus is typically a diamond having a cone angle of 90 degree and a spherical tip of 1 to 5 micrometer or even less. The stylus tip should be small enough to follow the details of the surface irregularity, obviously. If my tip is very large, if it is larger than the roughness or the waviness over the job, then it is useless for me. But should also have the strength to resist wear and shocks. So it should resist the wear and shocks. Stylus load should also be controlled so that it does not leave additional scratch marks on the component being inspected. So while I am just inspecting over this job, if my stylus is more sharper, then there is a high chance that it will leave an scratches over this job which will damage my job. So I should have some mechanism or a control system which can monitor the pressure over the stylus. So over a particular, I can limit only a particular pressure over the stylus. If it is exceeding that pressure, I should limit it using some control system. In order to capture the complete picture of the surface irregularities, it is necessary to investigate waviness, which is nothing but a secondary texture over the surface, in addition to the roughness, which is a primary texture over a surface. So generally in an industries, they will be just seeing the roughness, primary texture. If you want a costlier product, if you are going for a very good finishness, then you have to observe the waviness in that also. Then you need to correct in the next manufacturing unit. While a pointed stylus is used to measure roughness, a blunt stylus is required to plot the waviness.